Hello and welcome to an algebra video tutorial guide. We're learning about properties of exponents and how to simplify expressions with exponents. In this video, we just learned about the power of a power property in the video before this. In this video, I want to go over some examples of using the power of a power property to simplify expressions. And then also refer to some other properties. So we're looking at some more complicated expressions and looking at how we can apply exponent properties to simplify them down. And now that we know the power of a power property, let's use that as well too. The first one here, I've got -4 times a to the third times b. All of this, notice there's the grouping symbols, all of it is to the second power. All right. Well, one way I can approach this one is the second power. I can put it in an expanded form. So let's do -4 ab, a to the third b, times another -4 a to the third b. There's two of them, right? That's what that 2 means. And once I've set it up like that, now it's easy to see I have -4 times a cubed times b times -4 times a cubed times b. So we're expanding it all out, and it makes it really easy to see what we need to multiply together. Let's start with the real numbers. -4 times -4 is going to be 16. That makes sense. Now I have a to the third, but I have another a to the third. That's where I can add my exponents using the product property of exponents. So a to the third means 3a's times 3 more a's gives me 6a's altogether, 3 plus 3. And then with b's, I have 1b times another b. Well, that's b squared. So there's my final simplified result. This is the same as 16 times a to the 6 b squared. Now another way to think about this is everything inside is being squared. So that means the -4 is being squared to get positive 16. A to the third, I can use the power of a power property. A to the third squared, 3 times 2 gives me 6, a to the 6. And then b squared is just b squared. So if it helps you to write it out in expanded form, or if it helps you to think about all this is being multiplied so everything inside gets the second power, either way works. Let's look at another example here. Now I've got a fraction. I got 5 divided by x to the 7th, all to the third power. Well, we know previously that with a fraction, that third power affects everything in the numerator and everything in the denominator. So I can rewrite this as 5 to the third on top. But on the bottom, I already have an exponent, so it becomes x to the 7th to the third power. And you can see why we need the power of a power property to simplify this. 5 to the third on top is just 125. But on the bottom, x to the 7th, all to the third, I have 3 groups of 7 x's, which means I have 7 times 3, which is 21 x's. So it turns into x to the 21st power. All right, one more. This one is fun. Told you this was going to get complicated, right? So I've got all this stuff inside, 3 times n squared times n to the 5th divided by n to the 3rd, all of this to the 4th power. Now, one way I could do this is say it's a fraction, and I could rewrite as everything in the numerator and everything in the denominator gets the 4th power. So, the 3 to the 4th power, 3 to the 4th power is 81. M squared is also to the 4th power, so m squared to the 4th is a power of a power property, so I do 2 times 4, which turns it into m to the 8th. There's 4 groups of 2 m's. Now that 4th power also affects the n to the 5th, with 4 groups of them gives me n to the 20th power. 4 times 5 is 20. And on the bottom, n to the 3rd, all to the 4th becomes n to the 12th. That's one way you could approach this problem. I still have some stuff to do to simplify. Another way to approach this is simplify inside first. Well, But let's go back. Let's finish this problem off because we did not simplify things down, right? I have 81, I have m to the 8th, but notice I have n's on top and I have n's on the bottom. I can use my quotient property to subtract the exponents and simplify that down. 20 n's on top are going to be divided by 12 n's on the bottom. A bunch of n's are going to cancel out, leaving just 8 n's on the top. So when it's all said and done, it should be 81 times m to the 8th power times n to the 8th power as well. 20 minus 12 gives me 8. So that's the answer. But now let's look at another approach. What if I took this problem and instead of applying the 4th power right away in the power properties, what if I simplified some things first? What if I simplified n to the 5th divided by n to the 3rd first and did 5 minus 3? Well, that would give me, in parentheses, 3 times m squared. And n to the 5th divided by n to the 3rd is just going to be n squared. And all the n's on the bottom divided out. Well, now it makes it a whole lot easier to apply the 4th power and see that, well, okay, 3 to the 4th is 81. M squared to the 4th is m to the 8. And n squared to the 4th becomes n to the 8th. So I get the same answer, just a couple different approaches to it. And that's what you're going to find is we have all these exponent properties, the property of using quotients, the product property, the power of a power property. There's lots of different ways we can approach simplifying complicated exponential expressions. And it doesn't really, there's not really one right way to do them all. This way had a couple different ways I could approach it. Sometimes you have a few different ways you could approach a problem. Just make sure you're consistently using properties in the right way, and eventually you'll get down to what you need to get to.